What do you think? Anybody remember what this notation means? What's that mean? Anybody remember? Look in your notes. It's there. Transpose. And what does transpose mean?
Interchange the rows and columns.
Thank you. So, A transpose will look like this. So first row becomes first column, second row becomes second column. And then I'm going to multiply that times matrix B. Anybody remember the rules for multiplication of matrices?
Yeah, is that the same amount of rows and columns?
No, but part of it has to match. This guy is a 2 by 2, and this guy is a 2 by 2. In multiplication, they don't have to match exactly, just these have to match. Remember that? The answer then will be another 2 by 2. So, I gotta find two numbers and two numbers. You know, that's what I gotta figure out, those numbers. All right, look at what we did last time. Who remembers, what do we do here? How does this work? How do we find the numbers? We take the numbers in this row, and we multiply them times the numbers in that column. We multiply each pair and add them up. So that is 6. Come on, please tell me this looks somewhat familiar. We were doing this before we left. Now I'm going to take row 1 times column 2.
Negative 9.
So 1, 3, and 3, negative 4. Yep, I think you're right, Jake. Negative 9. Perfect. And then now I'm going to use row 2. And column 1. And column 2. So it looks like my bottom row is negative 12. Negative 26. Okay, that's how we do it. All right, so we did several multiplication problems the other day, and now we just did one here. If you have issues with that, go back and review those notes. All right? Because now we're kind of marching on to something different. We're going to find the determinant of A. So matrix A, I'm going to find its determinant. Now the notation for a determinant is just the vertical bars, not like the brackets, that's a matrix. For a determinant, it's just the vertical bars. Same numbers, but inside vertical bars. And the determinant is just a number, okay? And here's how we find the number. Look. I'm multiplying these two numbers together, and I get 5. I'm multiplying these two numbers together, and I get negative 6. And then I subtract them. So it's this product minus this product. So the answer to the question is just 11. That determinant is just 11. Always start here. It's always this one minus this one. Always. That's it. So what about B? What's the determinant of B? Laura says it's negative 24. Is she right? Yep, because it's minus 0. So that'll just be negative 24. Now C, it says find the determinant of C. That is a bigger matrix. So we are going to have a little bit of a different strategy. It's going to be a lot similar, but it's a little bit different because it's bigger. Okay? So there it is. Hopefully copied correctly. Alright, here's how this works. I want you to copy and paste the first two columns right here. So just take these two columns and reproduce them right here. So 1, 0, 1, negative 1, 3, 4. Don't rearrange them. Don't change any signs or anything. Literally copy and paste right there. Now we're going to multiply, just like before, when we started here, we multiplied those together. Only now we got 3 of them we're going to multiply. So we do the same multiplication, but it's bigger. So what's that? 0. Now, do this one also. What's that one when you multiply? 1. And then do this one, and what's that one? 0. Now, total those up. You're always going to have 3 of them because you're going to do 1, 2, 3. Total them up, so that works out to just be 1. Now, do you have a guess what I'm going to do next? The other way. Exactly. So I'm going to start down here, and I'm going to multiply those, and I'm going to get 6. And then I'm going to multiply those, and I get negative 4 and 0. So that total is 2. Now remember what you did with the little ones. You took that product and that product and you subtracted them, right? So guess what I'm going to do with my 1 and my 2? Subtract them. So 1 minus 2 is negative 1. That's the answer to the question. We're not going to do any bigger ones than that. All right, determinant of D. Oh, guess what? You can't find the determinant of D. What's wrong with D? They're not square. If it's not square, it doesn't have a determinant. So it's not square, so it can't be done. D cannot be done. There's no determinant for D. You can do a 2 by 2 and a 3 by 3, but you can't do a 2 by 3. All right. See if you can do problem 3 by yourself. This is a determinant like we just did, that big one right there. See if you can do that by yourself. Remembering that what's the first step? Copy and paste. It is so easy to make mistakes, and I do it all the time with these. I got 104. But I don't know if that's right.
Yeah, I got the same thing.
Okay, take a look at those numbers. Make sure you're getting 104. today's lesson is really about two things. It's about finding determinants. We've practiced that. Everybody good with 104? And it's about finding inverses. We're going to learn how to do that. And then we're going to use determinants and inverses to solve problems, okay? So we've learned how to find a determinant for a 2 by 2 and a 3 by 3. Now we're going to learn how to find an inverse, okay? So, matrix A, I'm looking at problem 4A. And here's matrix A. And my job is to find the inverse of the matrix. That's what that notation means, A inverse. Okay, now it's really easy. 2 steps. First step is find the determinant. Well, we already practiced that. What's the determinant of this matrix? 11. Alright, so just hang on to that number for a minute. We're going to use it in a second. Second step is build a new matrix by making a couple changes in the original. The first change is take these 2 guys right here. See where I'm pointing right here, these guys? And flip them. So put 5 here and 1 here. Flip flop those 2. Then, for the other 2 numbers, leave them where they're at, but change their signs. So since that's positive, I'm going to make him negative. And since that's negative, I'm going to make him positive. Now there's some real math going on behind the scenes here, but we don't have time to get into all that. It's easier just to remember that's what you do. You take these 2 and switch them. You take these 2 and change their signs. Now, take every number in that new matrix and divide it by the determinant. And that, my friends, is your inverse. That's all there is to it. A lot of times you'll have to simplify in here, but this time nothing simplifies, so that's just it. We're done. Now you're thinking to yourself, Mrs. Park, this is so cool. I'm so glad you taught me this, but what's the point? Let's take this inverse that we just got, and let's multiply it by the original matrix. Okay? So this is the inverse that I just got. This was my answer. And just for fun, I'm going to times it by my original problem. Let's see what happens when I do that. Don't let the fractions scare you. You have a common denominator. It's all 11, so it's going to be easy. First row times first column. I'm multiplying. So 5 11ths times 1 plus 2 11ths times 3. What does that end up equaling? 5 plus 6? 1. It's kind of cool. All right. 5 11ths, 2 11ths times negative 2, 5. What's going to happen there?
Probably the.
No, it's not 1.
Sure.
I'm positive.
Are you scared too?
100%. Kids, you're multiplying. So this is negative 10 11ths, and this is positive 10 11ths.
0
That's 0.
It's not what I thought.
All right. Negative 3 11ths and 1 11th times 1 and 3. What's going to happen there?
1, 2, 0.
0 again. And then finally, negative 3 11ths and 1 11th times negative 2 and 5. That is another 1. This is called the identity matrix, boys. I find this thrilling also, but I usually don't get quite as carried away as you guys are.
No, I got it before you, that's why I was impressed.
You got this 40?
No, I got that, I got the one before.
Oh, okay, you got that answer, perfect.
I was impressed.
This is called the identity matrix. And what just happened, kids, is what happens in regular numbers. So if you multiply 2/3 times 3/2, don't you get 1? Don't they cancel each other out? These are called inverses of each other. They're multiplicative inverses. When you multiply inverses, they cancel out. That's the whole point of having them. Anyway, this is the answer to the problem right here. All that was extra stuff. That's the answer. So now you're going to try another one. We're going to find B inverse.
Wait, Miss Ford.
Yeah.
Does this have to do with coding?
Does this have to do with what?
With like zeros and O's and the coding? Is that like the same?
Yes. These are called the basis vectors, and then yes, a binary system, absolutely. Yep. Your calculators and computers operate with matrices because it's one of the most efficient ways to do work. All right, B inverse. What's matrix B? All right, so here we go, guys. We're going to find the inverse. So who remembers the 2 steps to finding the inverse? Gotta find the determinant. And this is an easy one. The determinant is just -24. If you happen to do the determinant and get 0, it's possible. Then you know there won't be an inverse. Because if that number is a 0, you can't divide by it. So if by chance you get a determinant that's 0, you have what's called a non-invertible matrix. There's no inverse. Okay. Now I gotta build a new matrix. Remember how to do that? Don't, with these guys, just flip them. Don't change a thing, just flip-flop them. So -4 and 6. And then what happens to these two? So 0 is just 0, and positive becomes negative. Then we take all of these new numbers we just got and divide them by -24. So this one we are going to be able to simplify. So our inverse will be 1/6, 1/8, 0, and -1/4. All right, we're going to go to the calculator in a minute, but first I want to do D inverse, letter D. Tell me about that. Tell me about finding the inverse of matrix D. There's no determinant, and if there's no determinant, there is no inverse. So that problem is not doable. There is no inverse because you can't have an inverse unless you have a determinant. You gotta be square, okay? And D is not square. All right, now let's do M. Says here's matrix M. This is problem 5. This is what I was talking about a minute ago. Your job is to find the inverse. What's the determinant of that? Oh, watch it. That would be 8. That would be 8. That would be 8. But I subtract them. Remember, it's this minus this, right? So the determinant is 0, which means the inverse cannot exist. Because you can't divide by 0. Okay? Alright, now let's get our calculator out. Let's do a big one on our calculator. We're going to find the C inverse on our calculator. Okay, so everybody's paying attention here. We are going to go into our matrix menu, which for me is right here where this finger's pointing. See the word matrix? So I'm going to second matrix. And then across the top, you'll see your matrix menu. Edit, names, math, and edit. When we put a matrix into the calculator, you need to do it in edit. So go over to edit. This is how you put matrices in. Where's your calculator? Doesn't do as much good there, does it? Got a rent one, Robbie. Gotta have a calculator. Who else doesn't have one?
Make it bank today, Miss Ford.
Yeah.
56.
Next time you see me, I'll be wearing a new jumper.
Okay.
I got so many of them out here, I won't get my calculator back. Where's your calculator? Okay, it doesn't do us any good in our car, Katie. Right? Let me own it. I'll give it back when I get my calculator back. It says low batteries, I think it'll not. All right. Now I have to get one so I can press along with you. All right, so everybody's gone into the second matrix, right? Okay, you click across to edit and press enter. Now, particularly if you have a borrowed calculator, you probably already have stuff in there. Don't worry about it one bit. We're going to type right over top of it. The first thing the calculator wants to know is how big a matrix are you going to be putting in? What are the dimensions of matrix C? 3 by 3. So press 3, enter, 3, enter. Now, it'll set up for you then a 3 by 3 matrix and you start putting the numbers in. So just type the number and hit enter. And if you watch, it kind of goes across the top. And then it comes down to the next row. Now, this sounds so goofy, but one of the biggest issues we have is kids, you gotta use the negative button. That's where my finger is pointing right here. Don't use the subtraction. You gotta use the negative button, right? As soon as you get that last number in, is it a 0? And press enter. You gotta press enter for it to stick. Then I want you to second quit. So right here in the top row, second quit. When you are done entering your matrix, then we're out of edit now. You gotta get out of edit. So second quit. Okay? Now, go back into matrix and just press enter. And now you should see a matrix with A on your screen. You have a button that's an inverse button. It's X with a little -1. It's actually your matrix button. Press that button, not second it, just it. Press it. And then enter. And this is your inverse. Did you get -4, -8, 5? 1, 2, -1, 3, 5, -3. There's a way to do this by hand, but it's very tedious, and we're not gonna take the time to do it. So you need to be able to do a 2x2 on your calculator. 2x2 by hand, and then anything bigger than that, we'll just put in the calculator to get the inverse. Okay? Got it? What's the matter with you?
I got this far, and then I got lost.
You can just press the inverse. They're trying to inverse. All right. Since we've got everybody's got a calculator now, we're gonna go ahead and do the next calculator section. So that's, okay, so, by the way, you just finished 7-2. So that homework will be due on Wednesday. All right, 7-3. We're gonna skip down to number 2, solve using the inverse method on the calculator. All right. I want you to just bear with me for a second. If I had, let's say, 3x equals 6, and my job was to solve that, that means get x by itself, right? Which means somehow I gotta make that 3 go away. And you would probably think, I would probably think, let's just divide by 3. But we could also think of that as multiplying by 1/3. Would you agree with me? And then you would have x equals, you would have your answer. So your answer, you probably never really thought about this, but your answer is really just your constant, 6 in this case, times the inverse of that coefficient. So what I want you to see is this big system of equations in number 2a. The coefficient is 1, 1, negative 3, 2, 1, negative 1, 3, 1, and 5. Those are the coefficients, but they're functioning as one big coefficient. It's like this right here. Well, no, it's like the 3. So if I took the inverse of that, and multiplied it by the constants, that will be my answer. So just like in your original equation, you took the coefficients, took the inverse of that, and multiplied it times the constants, that's going to be the answer to the question. Okay? So here we go. We're going to put this matrix in our calculator. So second matrix, over to edit. How big is this matrix right here? I'm not doing that one. How big is this one right here?
3 by 3.
3 by 3, so 3 by 3. We put those numbers in carefully. Then you remember what you do after you get them all in? Second quit. Yep. Now, we're going to go back in to second matrix. So we're going to go over to edit. And now we're going to go down to matrix B because we have to put this one in also. Okay? So go over to edit, click down to B and press enter. How big is this matrix? What are the dimensions of this matrix?
3 by 1.
3 by 1. 3 rows, 1 column. So 3 by 1. Put in those numbers. and then you guessed it, second clip. Now, this matrix you called A, or at least I did, I think you probably did too. So what we're gonna type into our calculator is literally A inverse times B. So, second matrix, enter, that pulls up A. Now put your inverse on it, press your inverse button, and then times your multiply button, and then second matrix, go down to B and press enter, and now your screen should literally look like this. And then enter, and there's your answer. So X, the top number is X, this is X, Y, and Z. So the top number X is 3.5. Negative 3.25 and negative 2.25. Is that what you got? Hopefully. Did anyone else get that? Perfect. All right, so if you got lost in all that, here's the good news, there's another one. So one more. All right, so let's write down what we need to put into our calculator. We're going to put two matrices into our calculator. The first one is the coefficients. 2, negative 1, negative 1. Uh-oh, be careful. There's a 0, so it's going to be 3, 0, 1. And 2, 5, 0. Would everybody agree with that? That's X, Y, and Z. And then I'm also going to put in the matrix 1, 7, 6. I'm going to call this one A, and this one B, and I'm going to multiply A inverse times B. So second matrix, edit. A is a 3 by 3 again. Remember what to do after you get matrix A? After you get matrix A into the calculator, you have to second click, right? And then go right back in, second matrix. Go over to edit and down to B now. Now you're going to put matrix B in. It's a 3 by 1 again. Now you need to type this in on the screen. This is what it needs to say. So you go back into second matrix and just press enter. That pulls up your A. Put your inverse on that. Just press the inverse button. Times second matrix. Click down to B. Enter. And that, oh my, did you get some freakish decimals?
Yeah.
Okay, this is what happens when I just make up numbers and I don't rig it. So here's what I want you to do when that happens. I don't want rounded off. You'd have to round off to write this down. So here's what I want you to do, real simple. Press the math button. See where I'm pointing? The button that says math. And then enter. And it will change those decimals into fractions. So the answer to the problem, the answer to the problem, X is 46/27, 14/27, and 17/9. If they come out to be terminating decimals, that's absolutely fine. I don't have an issue with that. But if you have to round it off, Go ahead and just press your math frac, and it will change that way to the fractions for you. Got it? All right, let's set that aside. And now we're gonna do one by hand. Not a big one for this, but a little one by hand. So I want you to think about what you just did on your calculator. To get the answer to the question, didn't we take our coefficients, the inverse of those, times 8/3, isn't that what we did? So we're going to do exactly the same thing, only this time we have to do this part by hand. Okay? So we're going to do exactly what we just did. This is going to give us our answer, but we're going to do it by hand. So how do I find the inverse of a matrix? Find the determinant. So my determinant is -1 minus 6, -7. Make a new matrix. Now, these two are flipping places. These two are changing sign.
Put them all over
And you're
-7.
gonna go all over -7. So that right there, guys, is the inverse. So that's the matrix. I'm gonna clean it up a little bit. That'll be 1/7, 2/7, 3/7, -1/7. That's the matrix that I'm gonna take times 8/3. Don't freak out because of the fractions. It's a common denominator, so you don't need to worry about it. So you're gonna take 1/7 and 2/7 times 8 and 3. So what does that end up equaling? These are over 1. What does that end up equaling? 2. 8/7 and 6/7 is 14/7. So that gives you 2. And then take 3/7 and -1/7 times 8 and 3. And what's that give us? You guys are making it hard on me today. Come on, get those brains functioning. That would be 24 minus 3, which is 21 divided by 7 is 3. So the answer to the question is 2, 3. Remember, your answer is a point. On the calculator, if you were doing on the calculator, it would look like this. But that's a point, 2, 3. With your partner, do the other one there, do B. With your partner. You're going to do this exact process. Watch it, your determinant's 2, isn't it? -4 minus -6. You really have to be careful about that. I remember failing a quiz because I did that wrong. I know.
You failed a pretty tough
2 of them
quiz.
actually.
In
And
pretty
interestingly enough, no, I did this in algebra too, but, one of the quizzes I failed was this, and the other one was in English class, because I didn't read the story, and we had a quiz. I hadn't done my homework. Mrs. Silfoss called me up after class. She didn't even say, all she said to me was, Lisa, I'm really disappointed. I never not did my homework again. All right, here's what I got for my inverse, but I was talking and it could totally be wrong, so I'll wait for you to kind of tell me if that's what you got or not.
That's what I got.
For your inverse? So now all we have to do is multiply. Now remember, we're doing this by hand. So it's row by column. This is what I got, negative 19 halves, comma 13, but I'll wait and see if you match that.
I think it's right.
Well, I'm about due for a careless error, so. Which one? Who said wait?
I did, but I might be wrong. Oh,
What?
yeah, I'm not. Yeah. I forgot it, I did something.
All right? All right, we're gonna do problem 3 and then we'll be done for the day. But we need to get through problem 3. Would you agree that problem 3A looks very much like the one we just did? Yeah. So the difference is, remember how before we did some with substitution and some with elimination? But they're the same problem and the answer is the same. Now we not only have substitution and elimination, but we have this, which is called the inverse method, using inverses. And then we have what we're going to learn right now, which is called Cramer's rule. Now, this is one of the slickest things ever. Hero's formula is slick, so is Cramer's rule. This is pretty cool. Here's how it works. Again, you are looking for an answer like this. So you're going to find an X and a Y. The first thing you're going to do is find the determinant of the coefficients. So here are the coefficients. Make sure they're nice and lined up. There they are. What is that determinant?
Negative 11.
Oh, yeah, 7 negative.
17. It's 3, negative 14 minus. So it's 17. Kids, this minus this. That's how it is every time. Now, remember I said we're finding an X and a Y. These are going to end up fractions, and the denominator of the fraction is going to be 17. This number, the coefficient determinant, is the denominator of your x and y. Now, what are the numerators? Well, your x numerator, I shouldn't say equals, your x numerator is another determinant. When you built this one, these were the x coefficients and these were the y coefficients, right? If you're finding your x numerator, the number that goes right here, you cut these out, those extra numbers that we haven't used yet, and you paste them in the x column. So if we're solving for x, we cut these out and paste them here. So 9, negative 6, and then negative 7, 1. They don't switch places, nothing gets rearranged. You literally cut and paste. And then to do y, guess what? Same thing, only you cut and paste on y's. So that's going to be 3, 2, 9, negative 6. Now, evaluate this numerator, or evaluate this determinant, and that's what goes right here. All right, so here we go. 9 minus 42. Negative 33. Is that right, guys?
36.
And the next one is negative 18 minus 18, so it's negative 36. And that's it. That's the answer to the question. I love elimination. If I have to solve a system, I love to eliminate. But I also like Cramer's rule, because first of all, it's fast. I can do it all in my head. But secondly, this answer is yucky. This is not rigged. This is yucky. And if I were doing elimination, I would solve way and get x equals negative 33/17. And then what would I have to do if I were eliminating? Plug that back in and yucko, right? If I do Cramer's rule, I don't have to deal with fractions. They come out, but I'm dealing. All right, one more. Last problem, B, 3B. Solve with Cramer's rule. Can you remember the steps? There are 3 determinants you're going to find. Oh, that worked out. Now, I got -1 for my coefficients. Is that what you got? That's nice. It means my answers are going to be better. All right, now, again, don't switch anything. It's literally cut and paste. So cut them out and paste them right here on the X row. So that's going to be -7, 1, 2, 1. And then 5, 3, -7, 1. Those are your numerators. Everybody okay with this? Okay, that. I don't know why sometimes we switch things around. Just cut and paste. So I got -9 for that X and 26. So rewriting my answer, I got +9 and -26. How about you? That's what you would get if you did substitution or elimination or the inverse method. That's the answer to the question. Okay? All right, that's a lot for one day, guys. A lot. Let me get this in.